In this video we're going to look at adding and subtracting rational expressions, and these will all have the same denominators. They're usually the easiest ones to start with. This first problem here gives us a chance to see the two most common mistakes students make when they're adding and subtracting rational expressions. Starts off fairly easy. When you add fractions or subtract fractions, you just add the numerators and keep the denominators. Now in this case, the first most common pitfall students fall into is the subtraction part. You need to do one of two things. You either need to do 5x minus 7, subtract the quantity 2x plus 3, or you could just distribute the subtraction to start with. That's actually what I'm going to do. So I have 5x minus 7 over x plus 2. Now the first fraction doesn't change, but I'm going to distribute the negative, so that will make a negative 2x minus 3 over x plus 2. And you only distribute the negative into the numerator, not the denominator. At this point I can just put everything over the common denominator of x plus 2. And so I have a 5x minus 7, and then a minus 2x, and a minus 3. If you didn't distribute, you might put plus negative, or you could just do it in your head as you go. 5x minus 7 minus 2x minus positive 3. Just whatever way is easiest for you to do that. But in the end it comes out like that. At this point you're going to combine like terms in the numerator. So I got 5x and a negative 2x adds up to 3x. And again we're in the numerator. Also in the numerator I've got a negative 7 and a negative 3. Negative 7 and negative 3 add up to negative 10. And then the denominator I got x plus 2. The problem is actually completely simplified at this point. There's nothing else you can do. That brings me to the second pitfall students usually try to fall into, in that they try to divide these x's out. Well, you can't do that. Those are not factors. As you can see, this x is added to a 2 in the denominator, so it's not a factor, it's a sum. And students sometimes have a little trouble seeing that also, so what I like to show them is a simple example to let you see when you can divide out and when you can't. If you just consider 10 over 5, that's an easy fraction that simplifies to 2. 10 over 5 should simplify to 2 every single time you work it, no matter how you write it. So for instance, if I wrote 10 as 5 plus 5 and put it over 5, it needs to simplify to 2 because it's still 10 divided by 5. But if you follow the logic that some students try to follow, in that you can divide out terms, you end up, if you divide that out, some students rightfully say that's a 1. Well, 1 plus 5 makes 6. That can't be right because the answer is supposed to be 2. I won't go into all the other interesting explanations of this I've seen before, but basically in order to get this to divide out, you have to divide every single term in the numerator that's a sum or a difference by the entire denominator. So in order to get this problem to work correctly, you divide that 5 by the denominator and that 5 by the denominator, and that makes 1, that makes 1, and the answer is 2. So at this point on this problem, if we really wanted to get crazy and simplify some more, we could simplify this as 3x over x plus 2 minus 10 over x plus 2. But typically you don't need to go that far. This is most of the time the accepted answer. So you notice, back on this example one more time, you have to divide the entire denominator by each term that's added or subtracted in the numerator. So that's what I did down here. The entire denominator was x plus 2, and I divided it into the 3x, that's the first term, minus the 10 over the entire denominator. So like I said, typically that right there is good enough. Another example with the same denominators is this one here. You'll notice again, same denominator, so all I have to do is add the numerators together, keep the denominator. So I have 3x squared minus 6x, so plus and negatives of subtraction. This one can be simplified a little bit. Well, you say, I thought you said I couldn't divide out the x's. Well, the whole key a lot of times to adding, subtracting rational expressions is factoring and recognizing factors. In this case, you can actually factor the numerator. Well, I can see I have a 3 that'll go into a 3 and a 6, and x will go into x squared and x, and that leaves me an x minus 2. So 3x squared minus 6x is the same thing as 3x times x minus 2, and I want to divide that by x minus 2. Now, the difference between the problem from before and this one is these two right here, what I have highlighted in yellow and what I have highlighted in green, are both multiplied together. They're not added, they're multiplied. So you can divide things out that are multiplied. So in this case, what I'm going to do is I'm going to take the entire denominator and divide out that green term. So this actually simplifies to just 3x, because x minus 2 over x minus 2 will divide out, since this is a factor in the top, or in the numerator rather, and it leaves you 3x times a 1, which is just 3x.